first questions we're going to go through are half-life, doubling, and tripling. And if you have your phone out, you should really put it somewhere that's not near you, because you will be lost if you're not paying attention the whole time, which is how 30-1 works in general. This is not a different day. Okay, so this one is a lab tech placed a bacterial cell into a vial at 5 a.m. The cells divide in such a way that the number of cells doubles every 4 minutes. How long does it take for the cells to divide to produce 4,096? You don't need to write this. We'll go over that. Let's write down the. So the formulas we're going to use for doubling, tripling, half-life, sometimes they give you formulas on your test for different word problems, and sometimes they don't. But I always say memorize the formulas and then just use the ones you know. If you have your formula sheet handy, I would take it out and I would write this formula on the back of it so that you know when you go to study, any formulas on the back of your formula sheet you need to memorize. They're not given to you, right? Because you wrote them on the back and they're not giving you your formula sheet. So you need to memorize them. So any doubling, tripling, half-life formulas, doubling, I would title my formula this, doubling, tripling, half-life. So they're often like bacteria that are getting larger and they're growing exponentially so fast, and we're in an exponential unit, right? Or it's radioactive material that has a half-life of something and it's getting exponentially smaller faster, and you want it to get smaller faster because, say, the radioactive material is inside you because they're doing a test. You don't want it to stay there for life. You want it to have a very fast half-life to deteriorate it out of your body quickly, right? So if you have these, the formula is, I always say F equals I R to the T over P. F stands for final amount. I is initial amount. R is the rate. What the heck does that mean? If it's doubles, R equals 2. If it triples, R equals 3. If it has a half-life, R equals a half or 0.5. T is the time to reach final. And P is the half-life, doubling, tripling time. So final amount would be like after 10 years there was, or after 5 hours there was, or at the end of 3 hours there was 10 bacteria or something. That'd be your final amount of bacteria. The initial amount would be what you started with, right? R is just 2, 3, or a half, doubling, tripling, or half-life. The T and the P is what confuses people. So I always draw arrows so that I remember which one goes to, ooh, that would have been bad. Which one goes to which? So the T goes to F and the P goes to R. They don't distribute there. That's just what the time goes to. So P is the time it takes to half, double, or triple. So if it says to you it has a half-life of 4 hours, that means every 4 hours the amount you have is halving. Or if it says it doubles every 4 hours, the amount you have every 4 hours doubles. So it's going to get large fast, right? If I start off with 2 and that doubles, it's 4. That doubles is 8. That doubles is 16. That doubles is 32, 64, 128. And they're doubling. They're getting bigger faster, right? So they often start off with like a little bit of a pace like this, and then all of a sudden they grow really fast, right? Because if you double 128, it's just getting faster and faster growing, right? Okay. So P relates to R. If it says it halves every 50 minutes, I'd have a 50 here. The t relates to the final amount. So the t is time to reach final. Okay? So the t is how long it takes to reach the final amount. So they might be like, in 10 days, we have 1,000 bacteria. So it took me 10 days to get to 1,000 bacteria. That's my t. P is I have a half, it halves every 4 hours, then 4 would be in there. The key is that T and P have to be the same units. So if P is in minutes, T has to be in minutes. If T is in hours, P has to be in hours. Like they have to be the same units. So if one of them was a different unit, you'd have to make them be the same units. You should convert like minutes to hours or something like that. Okay. So let's write down what we do know. In order to solve, you can only be missing one variable. Just like when you're in physics or chemistry and you have a formula and you have to fill it in, the only way you can solve that for that using that formula is to have one unknown. The rest have to be known. Correct? We have an F, an I, an R, a T, and a P. So we have to have 4 out of 5 or we can't solve this. They could just ask us for the equation of something if they didn't give us everything, but they can't ask us to solve for something unless we have 4 out of 5 things. Okay? So a lab tech placed a bacterial cell. Because they didn't put 1, most people miss this. A bacterial cell is 1. Which letter would that go for? The initial amount. So the initial amount we have is 1. Into a vial at 5 a.m. Just because it says into a vial at 5 a.m. doesn't mean you need to use the 5 somewhere in the question. It's just that's when it started. So if they asked you how long it took in time, you could add it to 5 a.m., let's say. They're not going to, but. The cell divides in such a way, do bacteria usually get larger or smaller? Larger. So is it going to be a half-life? A half-life is going to make it get smaller. So like radioactive material, often half-life. Bacteria are often doubling or tripling. They're growing exponentially. You start off with a little bacteria and all of a sudden it's like covered in bacteria, right? So the cells divide in such a way that the number of cells doubles. Where do I put that? Thanks. Yeah, doubles, what are we going to put? R equals 2. Doubles every 4 minutes. Which is that? P. Because P is the period. It's how long it takes to double. Triple. Half-life. So P is 4 minutes. So my T is going to have to be in minutes. And often you're missing T or P. Why? Because then your variable's in the numerator or in the exponent, and you're solving an exponent, which is you're in the exponential unit. So often you're missing the T or the P, but sometimes you're not. Okay? Okay, and then we have how long does it take, so they're asking us for time, for the cells to divide to produce 4,096 cells. So what did they give me? And we're hoping that we're missing T. Does that make sense? How long does it take for the cells to reach that? So that's the time it takes to reach final amount is T. And they're asking us to find the time to reach final amount. So we should feel good about ourselves because it makes sense. Okay? So what's our formula? F equals I R to the exponent T over P. So we get 4,096 equals 1. R is 2. T is T. P is 4. Now, please follow along and do what I say. The very first step you should do for any of these word problems is divide the I over. In this case, the I is 1, so it isn't essential. It's not going to change my ballgame here, but we always divide the I over. Why can I divide the I over? Because both of them don't have exponents. So if both the 4,096 and the I both don't have exponents, we can put them together, can we not? That was what our agreement was yesterday. So we're going to divide by 1. I know this is foolish because dividing by 1 does nothing, but I'm just proving a point. Okay? So we have 4,096 equals 2 to the T over 4. We're going to solve this 2 ways. We're going to solve it by common base, if we can, and by calculator. Those are the only two ways we can actually do right now because we don't know how to do logs. Okay? You could solve this using logs. You have no idea how to do that. So right now we can't do that. But does common base always work? No. So in some of these questions, we might just have to use calculator for now. This one we can do common base. 2 to the what is 4,096? 2 to the 12? So equals 2 to the t over 4. And then I go 12 equals t divided by 4, multiplied by 4. And I get t equals 48 minutes. So it takes 48 minutes to get to 4,096. We're going to try this in our calculator, guys, okay? The reason why we're going to try this in our calculator is often people can't get a window enough to see this. So they like type it in, they're like, oh, I just can't get it to go. So we go to our calculator and we do y1, y2. Once it shows up. Come on. Come on. Join us. Okay. In this one, we're going to have 4,096 because that's divided by the 1, right? Which did nothing. And then we're going to have 2 to the, no. Okay. If your exponent does not pop up, so if your exponent has a little hat symbol, like it looks like this, you have to put your exponent in brackets or it doesn't know that that's the full exponent. If not, your calculator is going to go 2 to the power of x and then divide that answer by 4. Is that what you want? No. So if your exponent doesn't pop up, you have to put it in brackets, just like you have to put fractions in brackets, right? Okay. So we're going to imagine this graph, okay? The red one is the exponential graph. So we're going to press graph and we'll see the red one. Yay. So the exponential graph makes sense. It's going to start at small numbers, like 1 cell, right? And then it's going to slowly get higher, 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 and then all of a sudden it's going to get like big fast, right? That's called growing exponentially, right? So the y values get big fast. But I don't see the first equation on here. Why? My window is super off. That line is being drawn at 4,096. It's a horizontal line at y equals 4,096, right? My window maxes out at 55. So it's a little bit above it. And by a little, I mean a lot of bit above it. So I'm going to go down here to my y max and I'm going to make it be 4,100. Make my y scale be 500. If you left your y scale at 1, would it change everything? No, you just have so many little ticks, it would just look like a thick line instead of ticks. But is that going to make it so you can't see the graph or get an answer? No. Okay, so I'm going to press graph. Oh, dang it. Weird. Now my exponential doesn't look very exponential anymore. Where are these supposed to be, where we know, because we solved it already, where are these supposed to be crossing at? 48. Okay, let's look at my window. My x max is 20. Well, dang it. That ain't going to work. So I'm going to put a 50. Your calculator can only calculate where it crosses. Okay? Let's go back to 20 to prove a point here. I'm going to go to window. I'm going to make my x max be 20, which is wrong. And I'm going to go second, trace, 5, enter, enter, enter. And it says no sign change. Because if my calculator can't see where it crosses, it can't calculate where it crosses. We agree? So say you stink at Windows. No one told me this before, but it works. So say I'm really bad at Windows. I'm going to go to my red one or my blue one. It doesn't matter which one. And I'm like, I don't know what to make it be. So I'm going to just hold my arrow over and follow along my graph slowly and let my calculator do the work. And I'm going to be like, please start crossing, please start crossing, please start crossing, please start crossing. You can tell this is not the quickest method. However, it works if you're stuck. Please start crossing. Please start crossing. I'm going to go up to the blue one because the blue one's faster. Please start crossing. Please start crossing. Come on. Come on, calculator. You can do it. I believe in you. See, positive reinforcement on my calculator. Oh, look at this. It's getting better. This is really time consuming, just so you know. So I'm proving a point for those of you who think you're going to do this all the time. It's not the best method. Oh, come on. Come on. Boom! They cross! Woo! Second trace 5. So it worked. It was extremely time consuming. Okay? Yeah, so when I was in high school, I had these lovely TI-83s, and they don't move with you. You have to move the window for you. The new TI-84 pluses and some of the TI-84 pluses from before will move. But if yours is not one of those, you have to do the window yourself. No, you just do second trace 5 intersect, but you just have to let move it. It moves for you. So yours would do it, right? Yeah. Okay. So what value do we take? Always. What's our answer always? The x or the y? The x. Okay, our answer is always the x. 4,096 represents the y height at which this line crosses. But if I moved, the reason why we don't take the y is, is I could solve this equation up here. I could have solved it by moving this over by subtracting it, setting equal to 0, and then finding the x-intercept. And it'll still give me 48. So you can rearrange this equation all you want and do y1, y2. That's why the y doesn't matter. Only the x matters. So it's 48. Okay? All right. I want you guys to, we're going to look at this one here. So we have, what is the half-life? What does that give me? R of plutonium-232. So some people are like, there's initially 232 of plutonium. No, that is just an isotope of plutonium. Yay, who really cares? I don't care. So what am I going to do? I'm going to do this. So I don't try and put 232 somewhere in the question. Because it has numbers, it must go somewhere in the question, of course. No, it's just a type of plutonium. Okay? So don't go put that in an initial or something crazy like that. So what is the half-life of plutonium? So did they give me the half-life? They're asking me, what is the half-life? So the way you know if they're asking you to find P or if they give P is, did they give you the time around the word half-life doubling or tripling? So if we look at the previous question, it says it doubles every 4 minutes. That's really close to the word doubles, isn't it? So they gave me the doubling time, did they not? Here it says, what is the half-life of plutonium? What are they asking me to find? What is the half-life of plutonium? What are they asking me to find? How long it takes to half, which is P. So what is the half-life of plutonium-232? If in 204 minutes, what's that? It's time. It's not your P. P is how long it takes to half, triple, or double. Does it say that it halves in 204 minutes? No. If it doesn't say it halves in this time, or doubles in this time, or triples in this time, they gave you T. Okay? So this one doesn't say it has a half-life of 204 minutes. It says, what is the half-life if in 204 minutes a sample decayed? So they gave me the final time. If a sample decayed to 1/64th of its original, what is my original, my initial? You can make it be 1. You could make it be 100. You could make it be 7,342,000. You could make it be whatever you want. The easiest one to make it be is 1. Because final is 1/64th of whatever you make your initial be. So if I make my initial be 1, my final is 1/64th. If I make my initial be 100, 1/64th of 100 is 64. You just take the value and times it by 1/64th. So if you make your initial, if they say it's 1/64th or whatever, if you make your initial be 1, then your final's just 1/64th, which is way faster. If you make it be 7,322, you're going to have to times that by 1/64 and keep that awful decimal as your final, which would suck. So I like going with 1. So we have final, which is 1/64, equals initial, which is 1, times my rate, which is a half, and then 204 over P. Divide my 1 over. They're not always going to be 1. And I get 1/64 equals a half to 204 over P. And I can actually make these be common base. Make them both base 2. So 2 to the 6, 2 to the negative 204 over P. So I get negative 6 equals negative 204 over P. Multiply my P up. Negative 6P equals negative 204. Divide by negative 6. And P equals 34. Yeah, I think so. 34 minutes. Yeah. So I want you to type this one into your calculator. And I would reset my window back to standard. And then only change it if I can't see it. This one I'm going to set back to standard because they're both like 1/64th. That's not even 1, right? So it's going to be drawing a horizontal line at 1/61 over 1. 1 divided by 64, which is like 0 decimals, some crazy decimals. My answer is 34 though, so my x max is going to have to be at least 34 in order to see my answer, right? So whatever answer you get, if you're checking it, your x is going to have to be at least bigger than that. You're going to do number 10 on your own, and then we're moving on to a different type. Okay, so for this one, a culture starts initially at 3,000 bacteria. After 3 hours, there's 4,800 bacteria, so that's the final amount, right? And the time it takes to reach final amount. What is the doubling period? So they give us the rate is 2, but what is the doubling period? They're asking us to find P, right? So we do 48,000 final equals initial. Rate is 2 to the 3 over P. And the first thing I told you to do is always divide that I over. Then I think you get 16. Now, will they always work out nice and be common base? No, but they might. So this is going to be 2 to the 4 equals 2 to the 3 over P. So you get 4 equals 3 over p. Multiply the p up. So 4p equals 3. Divide by 4. And p equals 0.75 hours. So this thing doubles every 0.75 hours, so 3/4 of an hour, which is 45 minutes. Okay. So then we're doing appreciation and depreciation. So I'm going to get you to write this formula down. If it says something appreciates or depreciates. Yeah. They're going to look similar in the fact that the final and the initial will be the same. If something appreciates or it grows, the formula is final equals initial. And then we're going to take our 1 and we're going to add to it our interest rate to the n. This is a 1. When something depreciates, it declines or gets smaller. So we're going to do final equals initial, and then you're going to do 1 minus the interest rate to the n. No. So the reason why we do 1 minus the interest rate is going to be in decimal form. So 1 actually represents 100% of the original. So if something didn't grow, it would be 100% of what it was, right? If something didn't grow, it would just be 100% of what it was. And 100% in decimal form is 1. We agree? So if something is growing, we're going to take 1 and we're going to add to it our interest rate in decimal form. So it's going to take the original and add that interest rate, right? If something is declining or depreciating, we're going to take 1 and we're going to minus the interest rate from it. And it's going to be less than 1, which makes sense because if it's less than 1, it's actually declining. It's getting smaller. Okay? So F is still final. I is still initial. The only thing that changes is little I is interest rate. Interest in decimal form. Oh my. Yeah. And N is the number of years or months, etc. No, I'm good. So it's the number of years and interest rate in decimal form. Try this one out. So a car is worth $25,000. Is that initial or final? That is initial. Yes, it is. Oh, I'm recording. That's very. Okay, 25,000. And it depreciates by 15% per year. If it didn't depreciate, I would just have a 1 in here, would I not? Because 1 to anything is just what? 1. So if it's not appreciating or it's not depreciating or it's just staying, this value in here would be a 1. Because 1 to anything would stay the same. We'd multiply it. Boom. Our car stays the same price, right? But that's not the case. It's depreciating. So what do we have to do? Minus 0.15. Wow, that's really tiny. And they want to know the value in 5 years. So technically now, paying attention because they ask some questions like this sometimes, we have 25,000 to the 0.85 to the 5. When we had half in there, what was happening? When we had a half in the brackets, what was happening? It was halving. It was getting smaller. It was decreasing exponentially, right? What is another decimal for half? 0.5, right? So if it's depreciating by a half, that's what it would be. It would be 0.5. So it would be half of what it was before, right? This one now is 0.85 of what it was before. But that doesn't mean it's depreciating by 85%. So I'll give someone an equation like this and say, what's it depreciating by? And you guys will say 85%. It's not depreciating by 85%. 85% of it's left. So it's how far away from 1 it is, tells you if it's depreciating or appreciating. If it's below 1, it's depreciating. Below 1 by how much? 15? Well, then it's depreciating by 15%. If in that bracket I had a 2, it was doubling. It was getting bigger, was it not? 3, it was tripling. If I have 1.2, what's it appreciating by? Yes. So it's how far away you are from 1 to tell you how much you're going up by or how much you're going down by. If it's greater than 1, you went up, right? Because 1 is just you stayed the same, nothing changed, you have the same value. Greater than 1, you're going up by that much. Less than 1, it means you're going down, but it's how much less than 1 are you going down by? Does that make sense? So many of you guys tell me it's depreciating by 85%. No, it's not. How far did it go down by? 15. I am actually have 85% left, right? When I plug that into my calculator, what do we get? .63. Done. Fantastique. If you put 11,093, you're good. I didn't put a rounding rule, so yeah, woohoo. Yeah. No, we're good. I would accept that. I didn't say anything, so you go. Okay, so write these questions down, please. They are from different pages in the book because the book puts word problems in each section, which I just teach word problems together and then you do them rather than randomly doing them different things. So, so this looks ridiculous. However, it is 7 questions. That's it. Okay?